Close your eyes for a moment and imagine a world completely different from the one we know today. A world where all the continents were united into a single, colossal landmass. No Atlantic Ocean, no Pacific. Just one enormous supercontinent surrounded by a vast planetary ocean. This was Pangaea, and it existed more than 200 million years ago. The name Pangaea comes from ancient Greek, meaning all lands. And that's exactly what it was. All the Earth's land masses joined together in a configuration that would seem alien to us today. But Pangaea wasn't just a geographical curiosity. It was home to some of the most fascinating creatures that ever walked, crawled, or flew across our planet. Today, we're going to embark on an incredible journey through time to discover what happened to the creatures of this first supercontinent. We'll explore the bizarre animals that dominated Pangaea, the dramatic changes that transformed their world, and the legacy they left behind in the fossils we continue to discover today. Let's begin our journey in the late Paleozoic era, approximately 300 million years ago, when Pangaea was still forming. The collision of ancient continents created massive mountain ranges, some rivaling the Himalayas in size. The climate was extraordinarily diverse, with polar ice caps at the extremes and vast deserts dominating the interior. But what kinds of creatures inhabited this alien world? The answer might surprise you because during the early days of Pangaea, reptiles as we know them were just beginning their rise to dominance. The true rulers of early Pangaea were the synapsids, sometimes called mammal-like reptiles, though this term is somewhat misleading. One of the most impressive predators of early Pangaea was Dimetrodon. Despite its reptilian appearance, Dimetrodon was actually more closely related to mammals than to dinosaurs. This remarkable creature measured up to 15 feet in length and is instantly recognizable by the enormous sail on its back. Scientists believe this sail helped regulate body temperature, allowing Dimetrodon to warm up quickly in the morning sun, giving it an advantage over slower, cold-blooded prey. Dimetrodon wasn't alone in the food chain. The landscape of Pangaea was populated by an astonishing variety of bizarre creatures. There were massive amphibians, some reaching lengths of 10 feet or more, lurking in rivers and swamps. These weren't the small frogs and salamanders we know today, but formidable predators with powerful jaws and thick, armored skulls. As Pangaea continued to evolve, the climate became increasingly challenging. The interior of the supercontinent, far from any ocean, developed into one of the most extreme environments in Earth's history. Imagine a desert that stretched for thousands of miles in every direction, where temperatures could fluctuate wildly between scorching days and freezing nights. This harsh environment drove evolution in fascinating directions. Creatures had to adapt or perish. Some developed the ability to conserve water more efficiently. Others evolved tougher skin to protect against the intense sunlight and abrasive sand. The struggle for survival in the heart of Pangaea was relentless. Around 250 million years ago, the world witnessed the most catastrophic event in the history of life on Earth. Scientists call it the Permian-Triassic extinction event, but it's also known by a more ominous name, the Great Dying. This wasn't just another extinction event. It was the closest life on Earth has ever come to complete annihilation. Approximately 90% of all marine species disappeared. On land, 70% of terrestrial vertebrate species went extinct.
Notice the subtle tension and
the magnificent synapsids that had dominated Pangaea for millions of years were decimated. Entire ecosystems collapsed. The world that emerged from this catastrophe was fundamentally different from the one that came before. What caused this massive destruction? Scientists have proposed several theories. Massive volcanic eruptions in what is now Siberia released enormous quantities of carbon dioxide and other gases into the atmosphere, triggering rapid climate change. Ocean chemistry changed dramatically, with oxygen levels plummeting in many areas. It was a perfect storm of environmental catastrophes that pushed life to the brink. But life, as we know, is remarkably resilient. From the ashes of the Permian extinction, new creatures emerged to fill the empty ecological niches. The Triassic period, which followed the extinction, saw the rise of an entirely new group of animals. The archosaurs, the ancestors of crocodiles, birds, and most importantly, for our story, dinosaurs. The early Triassic landscape of Pangaea, was a recovering world. Forests were sparse, dominated by hardy conifers and primitive plants. The surviving animals were generally smaller than their Permian predecessors, a common pattern after mass extinctions. But evolution was already working its magic, preparing the stage for one of the most successful groups of animals in Earth's history. One of the most successful early archosaurs was Pangaea, a small reptile that measured only about 3 feet in length. This might not seem impressive, but Pangaea possessed something revolutionary: the ability to walk on 2 legs. This bipedal locomotion would become a defining characteristic of many dinosaurs. As the Triassic period progressed, dinosaurs began their ascent to dominance. Early dinosaurs like Herrerasaurus and Eoraptor appeared in the fossil record around 230 million years ago. These were relatively small creatures, agile hunters that likely preyed on the abundant smaller reptiles and early mammals that scurried through the underbrush. But not all creatures of Triassic Pangaea were dinosaurs. This period saw an incredible diversity of bizarre reptiles. There were the etosaurs, heavily armored herbivores that looked like a cross between an armadillo and a crocodile. There were the phytosaurs, crocodile-like predators with long snouts bristling with teeth, lurking in rivers and waiting for unwary prey. The skies above Pangaea were beginning to fill with life as well. The first pterosaurs took to the air during the late Triassic. These weren't birds, but flying reptiles with wings made of skin stretched between an elongated 4th finger and their bodies. Early pterosaurs were relatively small, but they represented a revolutionary adaptation: vertebrate flight. Meanwhile, the first true mammals were emerging. These weren't the large, diverse mammals we see today, but small, shrew-like creatures that lived in the shadows of larger reptiles. They were nocturnal, had fur to help regulate body temperature, and nursed their young with milk. These humble beginnings would eventually lead to the incredible diversity of mammals we see today, including ourselves. As the Triassic period gave way to the Jurassic approximately 200 million years ago, another extinction event occurred, though not as severe as the Great Dying. This extinction cleared the way for dinosaurs to become the dominant land animals. The age of dinosaurs had truly begun. But here's where our story takes a dramatic turn. Throughout the Jurassic and Cretaceous periods, Pangaea itself was beginning to break apart. The supercontinent that had existed for millions of years was fracturing along massive fault lines. Continents that had been neighbors for eons were drifting apart, separated by growing oceans. This breakup had profound consequences for the creatures living on Pangaea. Populations that had once been part of a single, interconnected ecosystem were now isolated on separate landmasses. The Atlantic Ocean began to open up, separating what would become North America and Europe from South America and Africa. The southern continents started their own slow drift, eventually forming South America, Africa, Antarctica, Australia, and India. This geographical separation led to what scientists call allopatric speciation. Isolated populations evolved independently, adapting to their new, separate environments. The dinosaurs of North America began to look different from those in South America. The creatures of Africa diverged from those in India. The unity of Pangaea was replaced by the diversity of separate evolutionary paths. Let's consider what this meant for specific groups of animals. The sauropods, those long-necked giants that we associate with the Jurassic period, had originated when Pangaea was still largely intact. As the continents separated, different lineages of sauropods evolved on different landmasses. Some grew even larger, while others adapted to different dietary niches. The theropods, the group that includes famous predators like Tyrannosaurus rex and Velociraptor, also diversified dramatically as the continents split. In South America, unique predators like Giganotosaurus evolved. In Africa, Spinosaurus developed its distinctive sail and semi-aquatic lifestyle. In North America, the Tyrannosaurs rose to dominance. Each continent developed its own cast of characters. The breakup of Pangaea also affected ocean life dramatically. As new seaways opened up, ocean currents changed. This affected water temperature, nutrient distribution, and marine ecosystems. New groups of marine reptiles, like the mosasaurs, emerged and dominated the oceans. The seas became highways for evolution, connecting and separating populations in complex patterns. One of the most fascinating aspects of Pangaea's legacy is what it tells us about biogeography, the study of how organisms are distributed across the planet. When scientists first proposed the theory of continental drift, one of their most compelling pieces of evidence was the distribution of fossils. Consider Lystrosaurus, a pig-sized herbivore that lived during the early Triassic period. Fossils of Lystrosaurus have been found in South Africa, India, China, and Antarctica. How could the same animal appear on continents separated by thousands of miles of ocean? The answer is that these continents were once connected as part of Pangaea. Lystrosaurus could simply walk from one region to another.
After the dinosaurs'
Similar
extinction,
patterns
bats
appear with
evolved
other
flight and
fossils.
echolocation,
The
becoming the only
distribution of
mammals to
certain
truly
plant
conquer the
fossils,
night
like the
sky.
seed
Their
fern
echolocation clicks
Glossopteris,
guide them through the
tells
dark,
the same
a testament to
story.
the innovative
These
power of
discoveries
evolution.
helped scientists
A
piece
massive
together the
elephant,
puzzle of
descendant of small
Pangaea
Pangaea
and understand
creatures,
that
now
our
dominates
continents
this
haven't
savannah.
always been in their current positions.
Its thick and rumbles
As we
echo
move toward
across
the end of the
African
Mesozoic
plains.
era,
The
the
ostrich,
world looks
largest
increasingly
living bird,
familiar,
evolved from
though still
theropods.
distinctly
Flightless yet
different from
powerful,
today.
its scaled legs
The
reveal
continents are
dinosaur
more
heritage.
separated, though not yet in their modern configuration. Flowering plants have appeared and are rapidly diversifying, creating new habitats and food sources. The first recognizable birds are flying through the skies, descendants
A
of
modern
small
lizard,
theropod
survivor of ancient
dinosaurs.
Pangaea, clings to this
Then,
rock. Its quick
66
movements
million
and alert
years
posture
ago,
reveal the
disaster
diversity of
struck again.
reptiles. Its scaled
An
skin tells a
asteroid
story of
approximately
evolutionary
6 miles in
continuity.
diameter slammed into what is now the Yucatan Peninsula in Mexico. The impact released energy equivalent to billions of nuclear weapons. The immediate effects were catastrophic. Massive earthquakes, tsunamis hundreds of feet high, and a shock wave that circled the globe. But the long-term effects were even more devastating.
On a flower
Dust
glistening
and
with
debris
morning dew,
thrown into the
ancient art of
atmosphere
pollination
blocked out
unfolds.
the
This
sun
lineage
for
extends
months
beyond
or even
Pangaea
years.
to earlier
Temperatures
supercontinents, a
plummeted,
timeless partnership
photosynthesis
continuing in our
stopped,
modern world.
food
A symphony
chains
of wings and
collapsed
pollen.
from the bottom up. The great dinosaurs, which had dominated Earth for over 160 million years, couldn't adapt quickly enough to these rapidly changing conditions. Approximately 75% of all species on Earth went extinct. The non-avian dinosaurs disappeared completely. The great marine reptiles vanished. The pterosaurs fell from the skies. The age of dinosaurs had ended, and the age of mammals was about to begin. But some creatures survived. Small mammals that could shelter underground weathered the
Look at
storm.
these layers.
Birds,
Classic
the
Pangaea
living
era
descendants of
stratification.
dinosaurs, made it
Incredible. This could
through.
be a therapsid.
Crocodiles and turtles, with their ability to go
Careful
long
now.
periods
We're on the
without
verge of a
food,
breakthrough.
persisted.
An ancient
These
synapsid
survivors
from
would
early
inherit the
Pangaea,
Earth
a direct
and
connection to our
diversify into
ancestry.
the incredible
Delicate
array
cleaning
of life
reveals
we
its
see today.
paleontological treasure, the texture of
So what
history
happened to the
preserved in
creatures of
stone.
Pangaea? The answer
Look
is
at that
complex
sail.
and beautiful.
It's incredible.
Some went
From 300
extinct
million
during the
years
mass
ago.
extinctions
It's
that
humbling.
punctuated Earth's
A true
history.
survivor.
Others evolved
connects
and
us to the
adapted
deep
as their
past.
world literally split apart beneath their feet. Their descendants diversified, filling new ecological niches on newly separated continents. The creatures of Pangaea left us an incredible legacy. Every mammal alive today, from the smallest shrew to the largest whale, from a bat to an elephant, can trace its ancestry back to those small, furry creatures that scurried through the undergrowth of Pangaea. Every bird, from a hummingbird to an ostrich, is a living dinosaur, a direct descendant of the theropods that hunted on Pangaea and its successor continents. The reptiles that survived, like crocodiles, turtles, lizards, and snakes, are living links to that ancient
The
world.
genetic code, a
Even the
molecular
fish in our
legacy passed
oceans,
down through
the
billions of
insects
years
in our
from
gardens,
Pangaea and
and the
beyond.
plants in our
A
forests have
continuous thread
lineages
of
that
life,
extend back to
connecting all
Pangaea and
existence.
beyond. The story of Pangaea teaches us something profound about life on Earth. It shows us that our planet is dynamic and ever-changing. The continents beneath our feet are still moving, still drifting, still reshaping the world. In millions of years, Earth will look completely different than it does today, just as it looked different millions of years ago. It also teaches us about the resilience of life. Despite catastrophic extinctions, despite dramatic climate changes, despite the literal breaking apart of continents, life persisted. It adapted. It evolved. It diversified. The thread of life that began billions of years ago has never been broken, passing from generation to generation, from species to species, continuously adapting to an ever-changing world. When we look at the fossils of creatures from Pangaea, we're not just looking at ancient history. We're looking at our own family tree. Those bizarre synapsids, those early dinosaurs, those tiny mammals hiding in burrows, they're all part of our heritage. Their success allowed our ancestors to survive. Their adaptations were refined and passed down through countless generations. The next time you see a bird flying overhead, remember that you're watching a living dinosaur, a creature whose ancestors walked on Pangaea. When you see a crocodile, you're looking at an animal whose basic body plan has remained successful for over 200 million years, since the time of Pangaea. When you look in a mirror, you're seeing a mammal whose distant ancestors survived the breakup of Pangaea and all the challenges that came with it. Pangaea may be long gone, broken into the continents we know today,
Listrosaurus fossils are
but
found
its
in South
legacy
Africa,
lives on
India,
in every
China,
living
and
thing on
Antarctica.
Earth.
This distribution is
The
impossible
creatures of
without
that
connected
first
continents.
supercontinent
Connecting the
didn't
dots reveals
just
Pangaea,
disappear.
a profound
They
scientific
transformed,
revelation.
evolved, and
After the
diversified into the
catastrophe,
incredible
the Earth
array
begins
of
its
life
slow
that surrounds us today.
From the
We are
crackling,
all children of
vast
Pangaea,
vegetation
carrying
begins to
forward the
return,
story of
showing
life on this
resilience.
remarkable planet.